Hello. So in this video, we're going to look at present value of an annuity and also some amortization problems. Now, you learn that basically if you have a cash layout, you can actually have those deposits sum to an amount that you would like to have in the future, um, whether it's to be able to spend or just have, whichever. But what if you had that you wanted to make withdrawal payments from an account until it's completely depleted? So to have that amount, it has to be set up. So the sum of all those payments or withdrawals is basically the present value of the annuity. But another way to think about it is that it's money that you wouldn't have necessarily at the moment. So then in that case, it's just being kind of like borrowed in the sense. It's more or less the same idea like whenever you purchase a vehicle, or if you're taking out like a student loan, or if you are going to purchase a home. Now, recall that basically with future value of an annuity, it was the sum of all these payments being multiplied by 1 plus I to the n minus 1 divided by I. Now, again, this was just the future value of an annuity. Now, I have a easy way of actually getting the formula for the present value of an annuity. So, for the present value of an annuity, we just have to think back to how do you get the present value with compound interest? So we have that we would take an accumulated amount and we're going to multiply this times 1 plus I to the negative n. Now, where we go from here is that we just have to insert an accumulated value. Well, in this case, that's exactly what this is right here. This is the future value of an annuity, so we can just substitute. So in this case, we have that we would substitute the equation. So we have PMT multiplied by 1 plus I to the n minus 1, all divided by I, and this is going to be multiplied by 1 plus I to the negative n. Now, basically, properties of exponents say that when you distribute the I, 1 plus I to the negative n, that's going to cancel out. So we'll just go ahead and say that we have that you end up with, and we'll call this PV. Okay, so PV equals to a payment multiplied by 1 minus 1 plus I to the negative n, and all of this is divided by I. Now, basically, this is what I call the present value of an ordinary annuity. Now, the parameters such as I and all that stuff, and it's all the same in terms of like, what they represent. So we have that the PV is basically the present value. You could also think of it as the principal, but in this case, it's the sum of all the payments. So this is the present value. The payment, well, it's the periodic payment in this case. Now, when it comes to the other bits of information, for example, like I is basically the interest rate per period. So in that case, it's just the R divided by M, where M is the period and R is the annual interest. And then N is actually the number of periodic payments total. So in that case, it'll be M times T, but T is basically in years. Okay, now, um, now one thing that I do have to mention is that in some textbooks, and especially in the previous video. Normally we might use like R as the periodic payment. So, it's more or less just like preference. The reason that we use R is to avoid having to say P times N times T because that gets confusing. But as long as it's clarified that this is merely just the payment, then you should be okay. And then usually the PV is marked as S, which in this case, yeah, we we are just solving for the sums of those payments. So it's really either or. But for simplicity, I just think kind of like PV, present value, PMT, payment, and so on. Okay, now let's try to use this formula, like for practical applications. So one of the most practical application that we can use for this is that um, is buying a home. Okay, so let's just move this over here. Okay, now we have that Frank and Maria have put 30,000 down towards the purchase of a house. Um, to finance the balance of the purchase price of the house, they agreed to pay a bank 950 per month for 30 years at 8% annual interest, charged monthly to pay off the mortgage loan on the house. Determine how much the house originally cost and how much the interest was paid. Okay, so there's a lot of information. So first off, the $30,000, that's the extra amount. So like if the house cost 70,000, then the purchase price would be um, well, I mean, basically like if they put 30,000 down, then that means that they financed the rest. So yeah, if it was like 100,000, then that means that they're financing 70,000 and so on. In this case, we actually don't know, though, how much is being financed, but we do know how much the payments are because it says right here that it's 950 per month. And then it's for 30 years. And then it's at an annual interest rate of 8%. Now, it does tell you per month, and it says per month also. So in that case, like, the period is monthly. So we're going to ignore the 30,000 for now. So let's go ahead and try to solve this. So first off, I know that the payment is equal to 950. The R is equal to 0.08. T is equal to 30 years. I think that's enough, really. Let's see. And then M. Okay, so M is equal to 12. Okay, so we're gonna have to use a calculator at some point. So we have present value is equal to 950 multiplied by 1 minus 1 plus 0.08 divided by 12 raised to the negative. Basically, you have 12 times 30, which is really negative 360 if you want to put that. And this is all divided by 0.08 and then 12, and then we just close it. So let's use our calculator at this moment. So we know that it's 950 multiplied by now what we can probably do is just use the expression so that way I can do this all in one, divided by 12. And then this one is going to be 1 minus, and then I just need to put parentheses 1 plus 0.08 divided by 12. Now, in most cases, I don't really need to see, what is 0.08 divided by 12. I know that in some instances, you'll be required, for whatever reason, to kind of know, like, yeah, like what is the interest divided by the period, but, we're doing approximations anyways, so I don't really need to see it. So we just press enter, and okay, so the house costs or the finance amount was 129,469 and 32 cents. Okay, so um, okay, so this is the amount that was basically financed. Okay, let's just double check. Okay, now the question actually does ask for the purchase price though. So um, the price is basically the amount that they put down, which in this case was 30,000, plus the amount that they financed for 30 years, 469 and 0.32. So the house is actually uh, the purchase price was 159,000 and then 469.32. Now, that's not a bad price when you think about it, especially especially right now, given that interest rates are very low. Um, so this is actually not really a bad price. However, what if I wanted to know the interest? Like like how much interest was paid, which is that's what this is asking as well. So I can go ahead and find the interest by looking at the amount that was paid back. So I know that they paid a $950 mortgage fee per month multiplied by the 360 payments that they made, um, minus the amount that they financed. So in that case, that was like 129, 469 and 32 cents. Okay. Well, the interesting thing that you might notice when you do that computation, and I mean we can use the answer, like the previous answer. Um, yeah. Let's see. Yeah, that should be good. 212. Okay, so they paid 212,530 and 68 cents in interest. So, okay, and I'll write it over here because I need to write something down there. So 212,000, was it 530, I think. Yeah, 530 and 68 cents. Okay. Now, the thing that I usually ask in class is like, what's the main thing that you notice? And the main thing that you will notice is that this amount of interest that they paid back. The amount of interest that they paid back is more than the purchase price. And then you could also kind of just think about like, overall, like how much did they pay for the house, um, in that sense. Because you're not even including the 30,000 that they saved. So it's close to a quarter million in that case. It's just shy. But that's mostly because of the interest rate. The interest rate was at 8%. So um, you see the 8% annual interest. That's why they paid back so much. So they usually say, for instance, that the more that you put down, the less that the payments will be. And then also like the longer, so like if they had extended it to like 35 years maybe, then in that case, yeah, that might lower the price a little bit. But this does not include like paying back something early or making extra payments, for instance. And 950, you don't feel it because, for 950 mortgage, you may not even notice, the amount that you're paying per month because you're actually purchasing, you're not renting. But then when you look at the end result, then that's where, you might see that the interest rates, uh, or the interest that was earned and paid back, that it's just way too high in this case. Now, one thing that I can do, for instance, is look at how much the balance got reduced on the first payment. So, for instance, if I look at the first payment, okay, and the question obviously is finished, but I like to explore, further into this whole idea of what amount reduced on the first payment. So, actually, it's like this. So we know that they financed 129,469 and 32 cents. Now you can find the interest that was due at the end of the month. So 0.08 divided by 12. So it's kind of like simple interest actually when you do it like this. So let's take and we're gonna have to just round. And for those that already have experience with this, you probably have an idea where I'm going with this. Okay, so the amount of interest that was owed is 863 and 13 cents. So we have that the amount that was due was 863 and 13 cents. Now, mind you that they have they have a they have a they have a monthly payment of 950. So, like, what if we went ahead and just looked at the payment? So, for instance, what if we looked at um, the payment that was made? So, we know that this was $950. We look at the interest rate or the interest that was due, and in this case, we have that that's 863 and 13 cents. Now, there's an amount that's going to go to the principal. Okay, so we can actually just do that by taking this amount and subtracting from 950. So that's 8687. That's towards the principal. So we have 80, not 87, but 86, 67. Yeah, or 87. 87. Yeah. Okay. Now, what this means is that this is going to be the unpaid balance in the next column. So we can put either the unpaid balance or the end principal. So I'll just put unpaid balance. That way, you kind of have an idea that this is the amount that is actually still owed. Now, how do you find that? You take the amount and you take the difference. In my case, I'm doing it backwards because I already have that it was negative, so that's kind of fine. 32. Okay, so let's see how much we reduce this by. So we reduce this to 130, 129, 382. And I think that was 45 or 43 cents, 45 cents. Okay, so we see that there is quite a bit to go in this case because you have that this is only just the first payment. Okay, so they have 359 to go until the balance eventually drops to zero. So eventually this will go to zero. But then you know that the interest paid back has to add up to what we found up here, which was the 212,530 and 68 cents. Now the payments, those are going to add up to whatever 360 times 950 is. And then the principal will be just the amount that was financed. So this is more or less what we call an amortization schedule. Or, if you ever gotten a loan or you've had a credit card, then in this case, it's kind of like a balance sheet, if anything. Now, let's go ahead and start talking about what is called amortization. Now, basically, the idea of amortization is to rid of some type of debt that you have. So, like for example, if I'm paying back a like a car note, and I have that there's like $2,000 left on it, I might actually get tired of it and just say, well, why would I need to pay this back over 5 years if I can just pay it back in 2 years? Or, for example, like if you have loans and you just want to get rid of that debt, and you're just like, okay, I need to get rid of this because I'm planning on purchasing a home. So in that case, like I might say, okay, if I have $8,000 left to pay back, um, and I want to get rid of it in 2 years, but it's due in like 5 years, then in that case, I'm trying to get rid of this debt as soon as possible, given the time. But the question becomes like, for instance, like how do you even do that? So hypothetically, you would actually not know the amount that needs to be paid back, but um, you would actually know the amount that's being borrowed or that's being paid back. So in that case, you do know PV, but you don't know PMT. So what that tells you is that basically that the payment has to be solved algebraically, and you do that um, by dividing the whole thing. Um, Now, most of the time, students will just get confused in terms of like how do you enter this into your calculator. I mean, you can always just do it one by one, if anything, because like mentioned just now, that we know that if we know the present value, and we know all this information, we just need to divide appropriately. This is just a formula just so that you can do it all in one. So amortization is when we're just solving for the payments in any case. So we can actually work out an example like that. So let's look at an example that deals with amortization. So let's say that the Reyes family buys a house for 250,000 with a down payment of 50,000. Find the monthly payment and the total amount of interest paid if the mortgage is for 15 years and the interest rate is 7%. Okay, so essentially the $50,000 is kind of like extra information. So in that case, we know that $50,000 was paid, but the amount that was financed was minus that. So that means that the present value is actually 200,000. Now, the other thing that we kind of can sift through this is that you know that it's a monthly payment. So in that case, M is 12 and R is 0.07, and then T is actually just 15. So this is like kind of like half of a typical mortgage. I mean, actually, it doesn't really matter. But you can just kind of look back at the previous example that this is like half that time. So we can expect that it's going to be a larger. It actually might be a larger payment, but it just really depends on given the the percentage amount. Okay, so this question is asking for the monthly payment and the total interest paid. So, okay, so let's go ahead and do this. Okay, so we have 200,000 multiplied by 0.07 divided by 12, and all of this is divided by 1 minus 1 plus the interest raised to the negative 12 times 15. Now, if you already know like what 12 times 15 is, then you can just enter that in. Okay, so, um, hmm. Okay, so let me do 200,000 multiplied by our 0.07 divided by 12. Okay, now I need to basically divide that amount, and mind you that you should never round before finishing the computation. So they usually say to avoid any intermediate rounding because it throws it off. Okay, so minus 15 times 12. And then I need to close that. So close it. Okay, so the amount that's paid back is 1,797 and 66 cents. So this amount is kind of it is higher definitely, um, but it still can be thought of like, okay, that's kind of manageable maybe depending on the house income. Yeah, okay. So this is the amount of the actually, I'm sorry. This right here should read as the payment. Okay, so it's just notation. And I guess that's the downside of having one of them be PV and then the other be PMT, so then you can easily just forget what we were doing. So PMT. Okay, so the monthly payment is this amount. Okay, so the question wants to know, though, is how much was paid, uh, how much was paid back in interest. So we can take the interest amount and we're just going to take the 17.97 and 66 cents. We're going to multiply that by 15 and 12, and we're actually going to subtract that from 200,000. Okay, so let's see. Now I am probably going to need to basically just round at this point, 66. So we multiply by 15, we multiply by 12, 12, and then we subtract 200,000. Now if we do this, that basically tells us how much interest was paid back. Still pretty high, to be honest, 123,000. Yeah. So the interest that was paid back was 123,000. 578 and 80 cents. Okay. Of course, if you consider that that this amount right here is about 323 1,578 and 80 cents, then that tells you that they paid they paid like basically almost 400,000 almost. I mean, well, if you want to be precise, they paid 373,578 and 80 cents towards the bank. Now, again, if you wanted to basically, so this answer is actually finished in this case, but let's say that you wanted to know, like, the balance. So, for instance, if we wanted to look at, like, let's say, like, the first two payments, we would have to basically just figure out how much was due on the first payment and how much was due on the second payment. Now, basically, interest due is kind of like simple interest. So we just have to take the 200,000 and we need to multiply by 0.07 divided by 12 divided by 12. So we unfortunately need to round. So we have 11.66 and 67 cents. That's the amount that's due. Okay, now we know that the payment, uh, let's see, we know that their payments is 17.97 and 66 cents. So minus the 11.66 and 67 cents. Um, let's see, $630.99 is going towards the principal. So that means that basically we have the payment of 17.97 and 66 cents. We have the interest, which in this case is 11.66 and 67 cents. The principal, is 630 and 99 cents. Now, basically, you could kind of say that this is the unpaid balance. Some people like to call it the end balance because basically you would want that the balance at the end would be zero, but that's not going to happen for a while. So the unpaid balance is basically just taking the uh, amount subtracted from the unpaid balance, which is in this case 200,000. So it didn't really get reduced by much, but that's better than nothing. So we have 199,000 and 369 and 01, 369.01. Now, basically, this has to do with the first payment. Now, if we were to, say, for example, do the computation for the second, we can actually do that. But we know that the amount that was paid back was, or the payment was 1796, or 1797 and 66 cents. Now, um, let me just make this negative again. That way, or wait a second. Um, Negative and then negative. Okay, so I need to find the interest that's paid back, or interest due. I keep saying that. So the interest that's due is 11.62 and 99 cents. So most of the payment is going towards interest actually. So we take the 17.97 and 66 cents and we subtract the interest that's due. Okay, so yeah, so 634. 634 and 67 cents. Okay, so basically you just take the difference of these two because that was the unpaid balance. So you have minus 199 369.01, and then this is the new balance. So 198 726 and let's see 34 cents. So the family does have quite a way to go because basically they just need to repeat this process until they reach the last payment, and then basically you have that. Hopefully, that'll just go to zero. Um, so in any case, like this is how most people tend to track. Um, you know how most people tend to track. The amounts that are being paid towards like something like a mortgage loan, student loan, credit card, and so on. Now, this wouldn't account for like if you decided to pay back early that amount, which in this case, you just need to figure out like what is the remaining payments. So, like for example, if you want to find like let's see. Yeah, basically like if you wanted to find like how much you have left, then it's something like you have 1 minus 1 plus I to the negative. So you have like n minus let's just use x, and this is divided by I. So basically, this would be like X would be how many payments you've made already. So basically, the present value of an unpaid balance, or yeah, if you want to know like how much is owed left. So yeah, like this is actually just a formula that just finds the unpaid balance of the amortized loan because basically you just have that you've made X payments and then all of a sudden you want to know like how much is left. So basically this just represents the unpaid balance of an amortized loan. So in this case, like basically, like if you wanted to know, like after the first payment, what was the unpaid balance, this potentially would actually solve that instead of having to go through all of the like the payments, for example. But the only problem with that is that what if I wanted to know how much interest was paid back after the fifth payment? Then in that case, this might be actually uh, not necessarily useful in that sense. But in any case, like this is pretty nice if you needed to know like the unpaid balance of an amortized loan, which you can actually use a graphing calculator technically to figure out those types of things. Okay, so that's going to be it. Hopefully you took more than actually what the material was over, in the sense that this is essentially kind of like a life skill that like most people should actually know. Like whether it involves like making huge purchases or making like decisions of having to borrow money in any case. So in this sense, it also actually lets you know kind of like how you could probably set up an account. And let's say that, for example, that you wanted to make withdrawals of, maybe like $2,000, per month, for like 20 years. So in that sense, you're setting up an account for yourself that you can make those withdrawals, for example. One of the most classic examples is like, what if I wanted to have $1 million and I wanted to be able to withdraw from that account for the next 25 years? Then in that case, I have to figure out like how much money would be put in so that account is set up such that when I make those withdrawals, that the account will go to zero in that sense. But you'll notice that if you set it up as a future value of an annuity, you're not actually, you're not actually paying back $1 million in actuality. So this is actually pretty useful in that sense, as it relates to, your present value of an annuities and future value of an annuities.